Beginning Unit 5 for Honors Math 3. Unit 5 is about radical functions. Radical functions are, square root functions, cube root functions, fourth root functions, so on. First off, definition, square root of x squared is equal to the absolute value of x. The absolute value symbols guarantee that we'll have a non-negative result. That's very important since even radicals, second roots, fourth roots, so on, do not allow us to get a negative result, to get a negative answer. Okay, so now, when we are doing square roots, and you guys have done this before, but when we're doing square roots, you're looking for pairs of things. So, for example, if you have a pair of x's being multiplied there, it's like on the outside, it represents one pair. In the notch, square roots, there is a little 2 that's in the notch. We don't write it. We understand that there is a little 2 in the notch. If you do see a little number in the notch, then it's probably something other than a square root, because square roots, we understand that if there is no number written in the notch, that it is a second root that we are looking for. Okay, so some examples. And really what we're doing today is we're simplifying radical expressions. Okay, so let's say we have this is really -1 times the square root of x squared. Okay, well, this is going to be -1 times whatever the square root of x squared is. Of course, the square root of x squared is the absolute value of x, and so this is opposite of absolute value of x. And you can't get rid of the negative, and without knowing what x is, we really can't do anything more than that. The answer, even whether x is positive or negative, really this is a negative value because you have -1 times a guaranteed non-negative. Okay. Number 2. Square root of x to the 4th. But yes, the problems will get harder than this, but we're just starting with just some real basic things. Of course, x to the 4th is x squared times x squared. So this is equal to the absolute value of x squared. Now, part of simplifying, if we can figure out that we don't need the absolute value, then you're expected in part of the simplification process to get rid of the absolute value. So, do we need the absolute value to guarantee that this is a non-negative value? We are dealing with real expressions here in the radical unit, and so the fact that x will have to be a real number, so no imaginaries. So if we're squaring a real number, can it give us a negative result? No. So really, the absolute value of x squared is just x squared, and we do not need the absolute value here because the answer, the absolute value symbols are unnecessary because x squared will be a non-negative result. Okay, number 3. Square root of x to the 6th. Of course, x to the 6th, x cubed times x cubed is x to the 6th. And so this would be the absolute value of x to the 3rd. Okay, now can I get rid of the absolute value? Well, what if x is positive? Okay, well, I wouldn't need the absolute value if x was positive. What if x is negative? If x is negative, a negative cubed is still negative. I need the absolute value because if I don't have them and if x is negative, I would get a negative result. And even roots cannot yield a negative result. Number 4, square root of x to the 7th. Okay, well, this one's a little bit odd because we've got x cubed times x cubed times, and then there's an x to the first. So we have a pair of x cubes, and so it comes out, we got absolute value of x cubed, and then the one that's left over has to stay behind, so x. Okay, so yes, this is looking like what that needs to happen. However, in the directions, it will say simplify, but we are also assuming we are working with real expressions. Okay, and now the directions don't always say this on every single thing, but this is essentially what we are working with the entire unit. We are assuming that we are working with real expressions, and that's part of what I was talking about, the fact that we're not going to have imaginaries there. But so if x is negative, a negative to the 7th power would be negative. And the square root of a negative is imaginary. And so assuming we are working with real expressions, therefore x cannot be negative. So x really cannot be a negative value. And so since x cannot be a negative value, we really do not need to worry about absolute value here on this one. And so therefore, the final answer is just x cubed root x. By the way, be careful when you're writing your exponents. Make sure that it doesn't get into the notch of the radical so that it doesn't look like a cube root. Okay, let's start getting to some other ones. This last thing right here, this is maybe one of the more confusing things for the whole unit. So keep on working on understanding what I just explained there. I'll keep on, when it comes up, I'll keep on trying to explain it to you. Okay, so we've got square root of 75 x to the 12th y to the 5th. Okay, now another thing that we're dealing with, if we have x's and y's or two variables going on, we will consider each variable separately. It just gets way too confusing if we start mixing the two variables. So let's just realize we're not going to stress about mixing the variables. By the way, instead of y to the 5th, I think I'm going to do y to the 3rd. Okay, so 75 is obviously 3 times 5 times 5, so we've got a pair of 5s. X to the 12th is x to the 6 times x to the 6, so pair of x to the 6s. And y to the 3rd, we've got y times y times y, so there is a pair of y's. Okay, pairs go out when we're dealing with square roots. So I would have 5 x to the 6th y and root, what's left behind, 3 and y. And so whatever's left behind, you just multiply it inside the radical. Okay, now technically absolute value, anything that comes out. Okay, now do I need the absolute value around the 5? No, obviously we don't need absolute value around the 5. Do I need absolute value around the x to the 6? Well, x to the 6, that's an even exponent out there. And so we don't really need the absolute value around the x to the 6, because even if x is negative, a negative to an even power on the outside will not give us a negative result. Do I need the absolute value around the y? Okay, now let's go back to where it was over here in the beginning, y to the third. We are dealing with a real expression here. Could y be negative? Well, a negative to the third power would be negative. And that means the whole value inside would be negative. And if we did square root of a negative, it would give us imaginary. Therefore, y cannot be negative. Y cannot be negative. Y has to be greater than or equal to 0, since it's a real expression. So we don't need absolute value around the 5, the x to the 6, and we don't need an absolute value around the y out here either, because y could not be negative and this be a real expression. Therefore, we do not need absolute value at all for this one, so it's just 5x to the 6th y root 3y. Okay, let's try one more of those. Let's say we had square root of 80 x to the 10th and y to the y to the 4th. Okay, so 80. Now you could break it all the way down to a bunch of 2's and then a 5. But something else you can notice, if you do the 5 first, you got 5 times 16, and 16 is 4 times 4. So obviously you could break down the 4's into 2's, but if you got a pair, you don't have to keep on going. So the 80 part is going to be 4 root 5. And x to the 10th is x to the 5th times x to the 5th, and y to the 4th is y squared times y squared. And so we have a pair there and there. So we have 4x to the 5th y squared absolute value around all that, square root of 5. Okay, now, do we need absolute value around the 4? No. Do we need absolute value around the x to the 5th? Well, let's see. Coming back to the beginning, could x be negative and this be a real expression? Yes. Could x be negative out here? If x is negative, negative to the 5th power is negative, and that is not allowed, so we will need absolute value around the x to the 5th. What about the y's? Well, even if y is negative, a negative squared would be positive, or non-negative at least, and so we don't need absolute value around the y squared. So final cleaned up answer here, we have 4y squared, and since none of that is in the absolute value, I'll put that out in front. Absolute x to the 5th square root 5. We do need the absolute value around the x to the 5th there. Okay, so moving on with our lesson, there's not a whole lot that I'm teaching you today that's new. I think you've seen just about everything that really is happening today. We're just making sure that we're clear on some of the details. The absolute value stuff, that is possibly some of the new stuff. So let's continue on. We're not dealing with just square roots. We'll also have cube roots. Now, if you have a cube root, you'll have a little 3 in the notch here, and you're looking for a 3 of a kind. Okay, so And eventually we're going to deal with fourth roots. And so if you're looking for a fourth root, you're looking for 4 of a kind. So, you know, x cubed is x times x times x, 3 of a kind, it comes out, so on. Now, odd roots work with negatives and positives. And so we do not need to worry about absolute value at all with any odd roots. Even roots, those are the ones that we need to consider the absolute value. Odd roots, we never need to worry about absolute value. So continuing on here, number 7. Let's say we have the cube root of negative 128 x to the 10th, y to the 6th. Okay, now they are real expressions, but a negative on the inside does not upset us when we're dealing with odd roots. Okay, so first off here, we've got, if you have a negative like that, you can just kind of peel it off all by itself. Isn't the negative, isn't that really negative 1 times negative 1 times negative 1? And so we have 3 of a kind that can get the negative, and the negative comes out. So when you have an odd root, don't leave a negative on the inside. You need to bring the negative on the outside. You don't necessarily need to show this work. It's just, this is what's happening. Okay, now 128. 128 is 2 times 64, and 64 is 4 times 4 times 4. So we've got 3 of a kind of the 4s. X to the 10th is x cubed times x cubed times x cubed times x to the 1st. And y to the 6th is y squared times y squared times y squared. Okay, I'm showing all kinds of work here. You don't necessarily need to show all this work. You need to show enough so that you're going to be accurate with everything. Okay, so final answer here. We've got negative 1, 4, x cubed, and y squared on the outside. So negative 4, x cubed, y squared. No absolute value needed because odd roots can give us positive or negative. And whatever's left behind, we got a 2 and an x left behind. So cube root of 2x. Okay, there is a little bit of solving here on this first worksheet, real basic stuff, and we've actually shown you some of this. I'm just going to remind you real quickly. So we are finding the real solutions. Okay, so all real solutions, not just a few of the solutions, but all the possible real solutions. Okay. So if we have x squared equals 121, and there's various ways to do this. You could bring the 121 over, have 0 on the other side and factor. That's one way. But one way we could do it, I could do the inverse operation of square, which is the square root. Okay, so square root both sides. Okay. Of course, what is the square root of x squared? Be careful about that because we're so used to just saying x, but the square root of x squared is not x. The square root of x squared is absolute value of x. And the square root of 121 is not plus and minus 11 because, you know, it's like we've talked about this before, but sometimes we see a simple question and we kind of revert to some quick things that perhaps were told to you earlier in your academic career. So even roots cannot give you a negative result. So the square root of 121 is absolute value of 11. Of course, the absolute value of 11 is just 11. Now, what values of x would give me 11? So if the inside is plus or minus 11, the absolute value of either one of those satisfies the equation. Therefore, x equals plus and minus 11. And those are both real values, and we need both of them for all the real solutions for this equation. Now that's doing everything we can possibly show in that part. You don't necessarily need to show every single thing, but you do need to be careful about all this sort of thing and make sure that you're considering it correctly. Okay, now, cube roots. If we have a cube root, couldn't we do the cube root of both sides? Okay. But if we look at the other side, and by the way, no scientific calculators, it's just the all-powerful little calculator, which has no cube root function on it. If you have maybe something like a decimal, you might want to rewrite it first. Okay, so how could we rewrite it? Well, how would I read this? Isn't this 125 thousandths? So this would be negative 125 over 1,000. Okay, and x cubed. Okay, well that looks a lot better. Let's do the cube root of both sides. Okay, cube root of x cubed is just x. And cube root of negative 125 over 1,000, of course, the negative is what I showed you on the previous problem. And we have the cube root of 125 over the cube root of 1,000. Of course, isn't 125 5 times 5 times 5? And isn't 1,000 10 times 10 times 10? So this is negative, and we would have 5 over 10. And of course, that is negative 1/2. And only negative 1/2. Now, could we have done that a different way? Sure, we could have done this a different way. If we had reduced 125 over 1,000 to begin with, that reduces to 1/8. And so if we did the cube root of that, you can see that we've got the negative, and the cube root of 1 is 1, and the cube root of 8 is 2, and so you could have done it that way as well.